Welcome to this new ABI Labs bonus video. Last year we released an exciting video collection split into 3 series covering the key tests, tips and techniques available with the ABI Bonemaster. If you would like to watch those videos, you can click the links on the right now or click the links in the description. In today's episode, we will be focusing on a key feature released in late 2020, giving you the ability to fully customize the test flow reports. We touched on this in episode 6 of series 3 of ABI Labs. By the way, if you are already an ABI customer, you can download the latest software by clicking the link in the description. Today's video will be a detailed tutorial, so sit back, relax and enjoy. To begin with, I will be showing you how to set up a report for a new test flow. Then we'll be looking at setting up reports for existing test flows. After that, I will be walking you through a completed report and explaining all of the saved information. And finally, we'll take a look at some advanced reporting features. Let's now have a look at how you would set up a report for a new test flow. Let's begin with the VI test on a resistor for step 1 of my test flow. I will select the 3D VI instrument and with my tweezers connected, I will start the test. This particular test technique was covered in more detail in episode 2, series 1 of ABI Labs. You can watch that video by clicking the link on the screen now. Now that I have saved my VI signature, I'm also going to add an image of my PCB. Once I have added this image, I will then set up my report. Within the Report Manager window, you can see all the different information you have available which you can store into your test flow report. Depending on which instrument you are using, you have different options available. You can also change the report title, which I have already done. This only needs to be done once. Since I am using the 3D VI tester, I will expand this. And you can see we have combined options and individual options. If I select VI data, this means in your report you will see a VI graph similar to what you can see within the instrument itself. If I select overall result, this means you will see the overall pass or fail as can be seen within the instrument itself. Near the bottom of the Report Manager window you can see test flow. If you want to capture any open instruments, this will mean that in your report you will see a screenshot of the instrument as well as any other open windows. So for example, I will also see the image of my PCB. If I select measurement result, this will mean you will see the overall test flow pass or fail within your report. Okay, fantastic. So before I move on into step 2, I will rename my step. For step 2 of my test flow, I am going to copy my first step because I want to use the same VI test technique and it will also save me some time. So if I click on copy step, you can see that everything has copied like for like. So before I begin the test, I will just quickly rename my step. Okay, fantastic. And I'm going to be testing an IC in this case, so I will change to clip. Select the number of pins my IC has. I also want to enable swept mode for a 3D VI signature. And now I will click start. I also want to change this image here to show the actual IC that I have connected to. So I will close this and I will locate the image of my PCB. Fantastic. So now I have the image of my PCB, I also have my results. I will stop, click store. You can see also within the Report Manager window that all the report settings have also been copied over from step 1. So all of this is already done for you. For step 3 of my test flow, I am going to use the ATM Advanced IC Tester as well as the programmable power supply, as this is now a power on test. Now that I have both instruments open, I am going to search for my part. And in the setup window, I'm going to make sure that I have selected all 5 tests and enable the PPS, which means the software will automatically control when my PPS turns on and off, as I am now carrying out both power on and power off tests. If you want to learn more about this, you can watch episode 5 of series 2. You can click the link on the screen now. I now have my results, so I will set up the report for this step. I want to see all the information in my report, so I will select everything. I'm also using the programmable power supply, therefore I want to see the channel data. Last but not least, I also want to see a screenshot of all the windows I have open. Brilliant. So now I'm going to rename this step before moving on to the next step. For my final step, I am going to use the MIS4 oscilloscope to measure the clock signal on my board. I will also need the power supply for this test. So before I start the test, I'm going to remove the channels I am not using. I'll also make sure that my settings are correct. Now I'm going to turn on my power supply and you should be able to see the signal. Brilliant. You can learn more about the MIS4 in episode 5 of series 3. Now that I've stored my signal, I will now make sure that my report is set up correctly. You'll notice with the MIS4 we have a lot more options available to save in the report itself. So what I want to see in my report is the amplitude, the frequency, and the period as well. In addition to these results, I also want to see a screenshot of my open instruments as well as the overall pass or fail result. So I'm going to select all of the test flow. Last but not least, I will rename my step. So now that I have completed my test flow, I can generate a new report. And in step mode or run mode, I can work through all of the steps. Once I have worked through all of the steps, I can then view my report and see all the test results in the end. Let's now have a look at how you would go about setting up a report for an existing test flow. Setting up a report for an existing test flow is easily done. So I have opened up my test flow which I completed previously. It contains 6 steps, and in edit mode I can simply set up the report for each of the steps. For step 1, I am using the 3dVI tester, and it also contains an image of the PCB schematic and also the PCB itself. So I want to see all of the information regarding the AMS3D-VI, so I would like to see the VI data as well as the overall results, so I'm going to select everything. I would also like to see a screenshot of all the open instruments within my report as well, so I will select Capture Open Instruments. For step 2, similar to the previous step, I want to select all of the options available with the AMS3D-VI. And I also want to see the screen captures as well in my report. For step 3, which uses the ATM IC tester, I want to see all the options under combined options, and I also want to see the part number of the device under test. For the PPS, I would like to see the channel data. And for the test flow, I would only like to see the measurement result. For step number 4, this uses the analog IC tester. I would like to select and see all options, all of the information within my report. And I would also like to see the open instruments. For step 5, I would only like to see the combined options for my test flow report. For step 6 of my test flow, I would like a lot more information, so we will start with the DSO. I would like to see the period. I would also like to see the top value, and I would also like to see the amplitude. For the MIS4 Universal I/O, I would like to see the channel output data. For the MIS4 Arbitrary Waveform Generator, I would like to see the channel 1 amplitude, duty cycle, and frequency. I will also like to see a screenshot of all the open instruments within my report. Now that I have set up the report for each of my steps, I can simply, in step mode or in run mode, I can generate a new report and then work through each of these steps, saving my results, which can be viewed at a later point. Let's take a look at all of the detail and the benefits of a test flow report in more detail. Let's have a look at a completed report. Starting from the top, we can see the report name. Underneath, we have the report details. So this includes information about the actual test flow file used to create the report. We can see who the operator was. We can see the date and time the report was completed. And we also have any comments regarding the report itself. Underneath, we can see the image of the PCB which was tested. We can see who the customer is, the part number, part name, revision, as well as the serial number. All of this information, including the actual diagnostic results themselves, are extremely useful for traceability and compliance. We have customers who use the report in many different ways. For example, some customers use the report as a way to create a database. We also have customers use the report as a way to quote their customers. So the report can be used in many different ways. We can see here in my first step, I tested the resistor R33 using the VI testing technique. We can see the VI signature, and we can also see the overall measurement, which was a pass. In step 2, I used the same testing technique, however I tested the LM324, which is an analog IC. In this step I used 3D VI, so voltage, current and frequency, and this allows me to sweep through the whole frequency range, allowing me to see how my VI signature changes depending on frequency. As you can see, we have the VI results for each pin of my IC, and I can sweep and see how the VI signature changes depending on the frequency. You can learn more about the VI testing technique in Series 1 of ABI Labs. We also have an actual screenshot of the instrument itself, and if I scroll down, we should be able to see an image of the PCB. We see this information because these windows were opened for this particular step. Further down in my report, we can actually see that this step failed. For this step, I tested the 7400, which is a digital IC, and I carried out 5 different tests. So the truth table, connections, voltage, digital VI and thermal tests. As you can see from the first table, we can see that a fault has been identified on pin 8 of that device. Comparing the voltages between the actual and the master, we can see there is a difference. In the table below, all the tests have passed except for the voltage test. So I know that there's a fault with the voltage on pin 8 of that device. Below this we can see the logic data for each pin of the 7400 IC, and we can also see the VI results for each pin of the IC. If you would like to learn more about the 5 different tests, you can watch this in series 2 of ABI Labs. Further down in my report, I tested the LM324, which is the same analog IC I carried out a VI test on earlier. In the first table we can see all of the different measurements from the test. In the table below we can see that I carried out a truth table, connections and voltage test, and we can see the extra information regarding the actual test technique itself. We can also see an actual screenshot of the instrument itself. And for this particular step, I was interested in seeing the current and voltage being drawn from the PPS. So we also have an image of the power supply instrument. In my next step, we tested the TLP621, which is an optocoupler. So we did a functional test on the optocoupler. Similar to before, we did a truth table, connections and voltage test. We can see the different data available, such as the CTR ratio, the voltage, and all the different measurements available for that particular test. I was also interested in seeing a screenshot of the instrument itself. For my final step, I carried out a parametric test on the same optocoupler, and I used the MIS4 and the multiple instruments available with it to do this. You can learn more about the MIS4 in series 3 of ABI Labs. Starting from the top, using the arbitrary waveform generator, I recorded the amplitude, the duty cycle and the shape. Using the DSO, I was interested in the amplitude and the base value. And for the MIS4 I/O, I was interested in the output data. You can see all of this information here. In addition to this, I was also interested in actually seeing the signal itself. Therefore, I wanted to see a screenshot of the instrument, so we can see the time and the voltage of the signal. And we can also see the arbitrary waveform generator and a screenshot of the universal I/O. I was interested in seeing the actual voltage and current being drawn from these 4 channels. Near the bottom we can see the time when the step was completed. If you would like to see only the steps failed, this is also possible. If I scroll all the way to the top, we have these 3 different options here. So if I enable show fail steps only, we can see the step that failed, which was the 7400 digital IC. If I only want to see the steps that passed, I can also do that by toggling show past steps. The report can be viewed on any browser, as well as your phone or tablet device. We have now seen the whole process and an example of a detailed report. It's also fully possible to customize the report, which we will look at now. Before looking at some of the advanced test flow report features, let's have a look at a completely standard report. So in this report, I do not have any results saved. I also don't have an image of my PCB, and you can also see the default HTML tags. Now all of this can be changed and customized, which I will show you now. In the System8 Ultimate software, I have already opened up my test flow. And in edit mode, I will click on setup report. You can see for this particular step, my report has already been set up, but I would like to change the report title. Under the advanced button, you can see we have 8 different user tags which can be completely customized. In the default report, which I showed at the beginning, we can replace those user tags here and add our own values. For my report, I want to change the comments, the customer, as well as the part number. So I'm going to change the first 3 user tags. If I replace user tag 1 with report comment, I can then add what I want to see in my report. For example, diagnostics on reflow oven PCB. I want to add the customer's name. And I also want to add the part number. Now that I have customized this, I can close the advanced setup. I can also close the report manager. And for this example, I will carry out a test only for step 1 and then we will view the report. Now I'm going to generate a new report. I will locate where I want to save my file and click save. In step mode, I am going to carry out a test for step 1 of my test flow. As you can see, my measured signal is not the same as the stored information, therefore this step has failed. We will be able to see all of this information, including the modifications we made earlier in the report. So if I now click on Review Report, starting from the top, we can see the report name. We can also see the comments, the customer, and the part number which we added earlier on. If I scroll down, you can see the VI result for step 1 of my test flow. If you would like to add an image of your PCB, and if you would also like to change the image at the top, for example, you can add your own company logo here. This will need to be done in your internal browser. So if I close the report window within the System8 Ultimate software, I locate where I saved the file. Now you can view the report in your internal browser. In this case, I am using Google Chrome. So, as the instructions say, you can double click here, locate the image of your PCB. You can also double click at the top and change the image. Fantastic. Now we have a fully customized report. To conclude, the test flow report is an extremely useful tool which can be used in many different ways, from traceability and compliance to using the report as a way to create a database to log common faults among PCBs, from using the report as a way to price up jobs, all the way to obsolescence management and numerous different ways. We hope that you enjoyed this bonus video. If you have any comments, feel free to drop them below, or you can reach out to us through our LinkedIn or our website. Stay tuned for the next video.